This is part 2 of section 5.5. We've been multiplying. Now we're going to talk about some special forms. These come back in the next chapter, and they're really important. I suggest that you learn these now. Okay? This form is called the difference of squares because difference minus sign of two squares. Okay? What we look at is if you're multiplying two binomials and you have the same first term and the same second term, but you have opposite signs. This is written with the plus first and then the minus, but it could be the minus and the plus. It makes no difference. If you have this pattern, all you have to do is square your first term, put a minus sign, square your second term. Okay? So let's follow this. If you look at this one, okay, we have the same first term, the same second term, we have a minus and a plus. So it fits this pattern. We square our first term, and you will get to where you do not need to write this down. Minus, you square your second term. Remember when you're squaring a term like this, you square each part. So this is 3 squared, which is 9, x squared minus 64. Okay? Now, if you want to see what's happening here, why we get to use this, let's multiply this out the way we did before. I distribute this 3x through here. 3x times 3x is 9x squared. 3x times 8 is plus 24x. Okay, now let's distribute the negative 8. Negative 8 times 3x is going to be minus 24x. Minus 8 times 8 is minus 64. You see what happens here in the middle? I have positive 24x minus 24x. They cancel out, and you get to right here. This happens every single time you have something in this pattern. Your middle terms are going to cancel out every time. So why go through this step if you know they're always going to cancel out? Just use the formula. Okay, so let's look at this one. 5r plus 4s times 5r minus 4s. We have the same two terms, opposite signs. We can go directly to our answer. If you square 5r, 5 squared is 25. R squared. It's going to be a minus. It's always a minus. It's a difference of squares. And then you square 4s. 4 squared is 16. S squared. And that's your answer. Okay. Looking at another one. I have 3r squared, 3r cubed, times x minus 4 times x plus 4. Now we have 3 things multiplied together. Well, technically 4 if you count the 3 separate from the x cubed. But so we can choose any 2 things to multiply together first. We can do that with multiplication. If you notice right here, we have x minus 4, x plus 4. That right there is a difference of squares. So multiply that together first. If I multiply these 2 together first, I'm no longer going to have a difference of squares, and it's going to be longer. You'll still get the same answer though, okay? If I multiply these 2 together first, I still have that 3x cubed, and I'm going to multiply that by, you square your first term, so x squared, it's always a minus, square your second term, which is 4, so 4 squared is 16. Now to complete this problem, I just need to distribute here. So I have 3x cubed times x squared, which is going to give me 3x to the 5th, minus 3x cubed times minus 16. Well, the minus is already here. And so 3 times 16 is 48. So you have 48x cubed. Okay, now your next formula is square of a binomial, okay? So I have either a plus b squared, all squared, or a minus b squared. It is important that you do not mix these up with this property right here. Here, 2 things are multiplied together, and we get to take that outer exponent and put it on each. Here, they're added or subtracted. Remember, in math, you often have separate addition rules, separate addition and subtraction rules than you do for multiplication and division. Here's a division that works pretty much the same way. You cannot just put that 2 on each one. It would be so nice if you could, but you can't. okay? Let me multiply this one out for you. A plus b squared is the same thing as a plus b times a plus b. Now you can work these problems by rewriting them this way and distributing. It works, but it's really not the easiest way, and I really want you to learn these formulas because they will help you out immensely in a future chapter, okay? But I'm just showing you what's happening here. And basically the same thing happens if the sign is a minus sign in the middle. If I multiply a times a, I get a squared. If I multiply a times b, I'm going to get ab. Now I go to the b times a, well that's also ab. And then b times b is b squared. Notice here that we have the same two terms and they have the same signs. When we were doing a difference of squares, they always canceled out because they had opposite signs. When you're squaring a binomial, whether it's a plus or a minus, you're going to have the same signs right here. So you combine like terms to get a squared plus 2ab plus b squared, which is what we have right here. That 2 comes because these are always going to have the same sign and you get to combine them. Okay? If this is a minus, these are both going to be subtractions and you'll get a minus sign right here. Okay? Now, the way to talk yourself through these, if you look right here, what we're doing every time is you take your first term and you square it. A squared, a squared. You write down the sign from the middle, a plus, a minus. Then you multiply these two things together, which is your AB, and then you double it, multiplying it by 2. And then you add, this one is always addition, you square your last term. Okay? So if I work through this, talking through it that way, I'm not worried. I don't have to memorize both formulas. If I talk myself through it the same way, it always works. You square your first term, which is x squared. You write down the sign from the middle, minus. Okay? Multiply these two things together, which would be 3x, and then you double it to get 6x. So it's minus 6x. I don't have to worry about the sign when I'm doing this because the sign is already taken care of. Plus, because that last sign is always plus, you square your last term. 3 squared is 9. I'm directly to my answer. Now, I can write it as x minus 3 times x minus 3. It works, but I really want you to at least practice using it this way. Okay? Well, now let's try this one. 4n plus 3m squared. Square your first term. So you square the 4, you square the n to get 16n squared. Write down the sign from the middle, which is a plus. Okay? Now multiply these two things together, which would give you 12mn or nm, it doesn't matter. And then you multiply it by 2, and you get 24mn. You are usually going to be able to do this in your head or on your calculator. So I get 24mn or nm plus, because that last sign is always plus, square this. 3 squared is 9m squared, and you have your answer. Okay, one more of these, x minus 7 all squared. Square your first term, x squared. Write down the sign from the middle, minus. Multiply these together, 7x. Multiply that by 2 to get 14x. So minus 14x plus 7 squared is 49. Okay, one more tiny little topic. We talked about the polynomial notation for addition and subtraction. We also have it for multiplication. If you see FG with nothing between them, no addition, no subtraction, just FG, they're wanting you to multiply them. So just like we took, if this was f plus g, we found the f function, we found the g function, we added them together. We do the same thing here, except we're multiplying them, okay? So if f of x is 3x and g of x is 6x minus 8, they want us to find f times g of x. So f g of x is f of x times g of x. So this would be 3x times 6x minus 8. So what do we need to do? We just need to distribute. 3x times 6x is going to be 18x squared. 3x times negative 8 is going to be minus 24x. And that's your answer.